Good day to you. I'm Dr.R.Radha, Assistant Professor of Chemistry from the Standard Fireworks Rajaratnam College for Women, Sivagasi. Today, I'm going to discuss with you about Organic Chemistry, General Chemistry 1. The topic is hyperconjugation. So, in this model, the learning objectives are to understand the concept of hyperconjugation, to know about the structural requirements in the molecule to show hyperconjugation, and to learn about the importance, consequences and applications of the hyperconjugation. Electron displacement is an organic molecule may takes place due to the presence of an appropriate attracting reagent. This kind of electron displacement leads to polarization of the bond. In conjugation, we have studied that the electrons move from one p orbital to other which are aligned in parallel plane. It is possible for electron to jump from p orbital to sp3 orbital that are not parallelly aligned with one another. The answer is yes. The type of conjugation is not normal. This is why extraordinary. Hence the name hyperconjugation. It is also known as non-bond resonance. So let us study more about it. So hyperconjugation effect is a permanent effect in which localization of sigma electrons of CH bond of an alkyl group directly attached to an atom of the unsaturated system or to an atom with an unshared of p orbital takes place. In this figure, we observe that one of the three CH bonds of the methyl group can align in the parallel of the empty p orbital, and the electrons contributing the CH bond in a plane with this p orbital can then be delocalized into the empty p orbital. So, the normal electron releasing inductive effect of the group in the following order, that is the increasing order of methyl to tertiary butyl. But it was observed by Baker-Northern, that is the conjugated system, the attachments of alkyl group reverse their capability of electron releasing. They suggested that the alkyl group are capable of releasing electrons by some process other than inductive. That is, when a CH sigma bond is conjugation, the sigma electrons of this bond enter into the conjugation. This is an extension of normal conjugation, and the term was hyperconjugation. Unlike the normal conjugation wherein the pi electrons get delocalized in p orbital, here the sigma electrons move to p orbitals. It involves the delocalization of CH sigma electrons. It essentially means that hyperconjugation depends on the presence of alpha hydrogen atoms. With the increase of the number of such hydrogens, the electron releasing effect of alkyl group was increased. So, the contributing structures involved sigma electrons of CH bond do not show any covalent bond between carbon and hydrogen. So, the hyperconjugation therefore is called as no resonance. It is important to note that the hydrogen does not actually separate from the molecule, because if the hydrogens, the necessary condition for resonance to occur will be violated. So, hyperconjugation exists in the molecules as the following framework, that is either alkanes or carbocations or free radicals having at least one alpha hydrogen but not in carbon ions. So, this is the example for the hyperconjugation in propene, and the other system is hyperconjugation in toluene. So, condition for the hyperconjugation. There are various conditions for hyperconjugation was developed. The first condition is the presence of a lone pair of an alpha CH group was attached to the sp2 hybridized carbon alkenes, alkyl conditions and free radicals, or other atoms of elements like oxygen, nitrogen with alpha hydrogen and so etc. The double bond becomes polarized as a result of s electrons being displaced away from it by hydrogen presence and the alpha carbons. Therefore, the hyperconjugation effect can be observed in alkyl carbocations alkenes, alkyl free radicals and some nitro compounds with alpha hydrogen. So, consequences and applications of hyperconjugation. The first one is the stability of alkenes, then stability of carbocations, stability of free radicals and dipole moments and bond angle calculation, reactivity and orientation of the electrophilic substitution on benzene ring and anomeric effect. These are the some applications for the hyperconjugation. So, herewith we discuss about the stability of carbocations. The ethyl carbocation is more stable than the methyl carbocation. This is because the sigma electrons of the alpha CH bond in ethyl group are delocalized into the empty p orbital of the positive carbon center and thus by giving rise to no bond resonance structures as shown below in the structure. But hyperconjugation is not possible in methyl carbocation and hence it is less stable. In general, as the number of alkyl group, that means the containing hydrogens attached to the positively charged carbon increases, the stability of carbocations will increases because of the increase in the number of contributing to the structure to hyperconjugation. So, this is the stability of the carbocations. The increasing order of stability carbocations as below. That means the increasing order to the methyl to methyl and then primary and then secondary and tertiary. So, tertiary carbocation is more stable than methyl. So, these are the some questions which are discussed in the hyperconjugation. So, summary of the hyperconjugation. The delocalization of sigma electrons or lone pair of electrons into adjacent pi orbital or p orbital is called as hyperconjugation. It takes place because of overlapping of a sigma bonding orbital or the orbital containing a lone pair with an adjacent unfilled p orbital. It is also as non-bond resonance or Baker-Nathan effect. It is also explain the stability of alkenes, carbocations and free radicals. The dipole moment of the molecule and bond length is greatly affected due to the hyperconjugation since the contributing structures show considerable polarity and charge in bond order. The hyperconjugation also explains the reactivity and orientation of electrophilic substitution and alkyl substituted benzene rings. The overall tendency of anomeric substituents to favor an axial position is called anomeric effect. For example, the alpha methyl glucoside is more stable than the beta methyl glucoside due to the hyperconjugation. For alpha haloalkenes, the delocalization of the electron takes place towards the halogen group through hyperconjugated mechanism because of electron withdrawing nature of halogens. It is known as reverse conjugation. Thanks for watching this video. We will see the next module.